I'm predicting that today's video should be a pretty short video. Don't quote me. We'll see at the end how long it took us to get through. I know it's very difficult to see the learning outcomes on this video, but you have it on your paper. You can just look along. It says students should be, at the end of today, should be able to choose and interpret a scale on a graph to approximately represent an exponential function, plot points representing the number of bacteria over time, given that bacteria grow by a constant factor over evenly spaced time intervals. Again, we're going to skip question 2 until tomorrow in class because it's another video that we have to watch. I am also going to go over the closing tomorrow when we actually do the lesson. And the exit ticket you guys will try tomorrow as well. I'm going to concentrate on this number 1 right here. So it says below are 3 stories about a population of a city over a period of time and 4 population versus time graphs. So we have 3 stories, 4 graphs. 2 of the stories will match a graph. 2 of these graphs will not have a matching story. We'll have to come up with that. And 1 of these stories will not have a graph, so we'll have to come up with a graph for that. So story 1. The population size grows at a constant rate for some time, doesn't change for a while, then grows at a constant rate once again. Constant rate means it's going to be a straight line. So it grows at a constant rate, but then it says it stops for a while, so it can't be A. Can't be B because this isn't constant when it occurs. Can't be C because C decreases. It never said anything about decreasing. It's got to be D. It increases for a while, stays constant, and then increases at a constant rate again. Story 2. The population size grows somewhat, then the rate of growth slows down. So the population grows somewhat, and then it slows down. Some of you might think A, but that's just constant the entire time. It's more along the lines of B. It grows at a constant rate, but then the rate is slowing down. So that's where you get that curve part from. The population size declines to 0. You'll notice none of these graphs end at a population of 0, which hits the x-axis. So since none of them hit the x-axis, that can't be part of that can't be any of the graphs. Part B says write stories for the other 2 graphs. Well, we didn't use letter A. Letter A, the population's just increasing constantly over time. Letter C, the population increases, then decreases, then increases again over time. And that's what you'll see I have listed here. Again, the population increases at a constant rate for graph A. The population increases, then decreases, then increases again for graph C. Part C, draw a graph to match the 3rd story. Remember the 3rd story said the population declines to 0. Could be as easy as this one. Notice I did label my axes. Population over time. It starts at something but then declines to 0. But maybe it looks more like this. It starts at some kind of population but then slowly decreases to 0. It's not a constant rate. Okay. At this point, we will look at the rest in class tomorrow. We're also going to spend probably some time reviewing tomorrow as well for our exponents quiz.